Okay, recording is started, and welcome to the Correlational and Non-Experimental Design webinar. As you know, we have been experimenting with a new wonderful tool called DBL, Decision-Based Learning, and we are in the process of learning. And we are, at least in my case, this presentation was developed while we acquired DBL. So what I had to do is use a combination of a regular presentation, and then we switch into DBL, where we go into a series of challenges and questioning. So this is going to be a four-fold presentation. First is presentation on correlation all the way to assumptions. And then we're going to switch to DBL, and I'm going to be asking questions when we're going to go some challenges. Then I'm going to come back to the presentation where we're going to cover mediation, and then we're going to switch back to DBL. I would prefer that you ask questions at the end, and trust me, you're going to have enough time to interact and play with the design. So we have two kind of correlational designs, the relational and the predictive. And this is also called a non-experimental, because usually you don't manipulate the variables. You find the variables as they are, and even if you provide some sort of changes, is not considered an experimental research as the comparative ex post facto designs are. We're gonna, cover when to use, the types, characteristics. We're gonna talk about the assumption and mediation. Be aware that linear regression correlation are a very demanding statistical test. By no means I'm going to cover everything that needs to be covered, but I will give you enough for you to continue your search. And then especially, we're not going to cover all the assumptions, but just a couple. If at any time, Ryan, I lose or you lose me or something, let me know immediately, please. You can always also example I use in my statistics class is the cost of Subway and the cost of pizza in New York. They are highly correlated, but that doesn't mean that highway, the cost of the Subway drive the cost of pizza or vice versa. No. So again, we want to use linear regression when we want to predict an outcome based on the manipulated condition from the independent variable. And it's a little bit forward from the pure correlation, right? We can predict an outcome with the linear regression equation. We're going to see that in a few. We can have simple regression, mean one independent variable, age, to predict sickness, right? Or how much diabetes you can have. I'm making this up. Or you can have multiple regression, where you can have age, experience, how beautiful the model is to predict salary, for example. Imagine I was interested in predicting physical and downloaded album sales. That's the outcome. From the amount of money spent advertising that album predictor, and then we can summarize this relationship using a linear model. Look at the equation right here. So in this case, and that's what is called the linear regression equation. In this case, Y is the predicted value, album sales. B is the y-intercept, and I will see what the y-intercept is. B1 is the slope of the equation going up. E is a standard error because we never predict 100% accurate. And then we only need to plug the value of X, in this case, advertising budget. So once we get this equation, and then managers use this all the time, then they say, okay, if I spend $350,000 a year in advertising, I'm going to be making Y album sales. And you only have to plug the values of the linear regression. That's what this is used for. Very practical. So that when I said the intercept mean when X is 0, this red right here is the y-intercept. That's the B0 in this equation. B0 is the y-intercept. And then you have to be plugging the values of X coming from X from the left to the right. And then once you put the values of X, the slope is going up. And that's what they mean with the B1, the slope. And then we don't use E, although it is in the equation. It is in the linear regression analytical test. We can conduct linear regression with interval variables, categorical variables, and a combination of both. To be able to use categorical or multiple regression, we need to create n-1 dummy variables. For example, if we have 3 groups and we want to run multiple linear regression, the below table shows the needed code. In this case, the regression is regressing false memory, that's the dependent variable, against 3 groups of independent variables represented by women either abused with post-traumatic disorders, abused without PTSD, and non-abused without PTSD. So you can see we create 2 variables, not 3, but 2, because n-1. And then we enter this into SPSS exactly as it looked like. It would look the same in Excel. And then in the first one, let's look at the next one, because it says the results as in the multiple regression, the first dummy variable will contrast the abuse PTSD with the non-abuse and non-PTS group represented by 0. And the second dummy variable will compare the abuse non-PTS represented by 1 with the non-abuse group. And that's how we do linear regression with categorical variables. If you have interval variables or continuous variables, you don't have to do this. You only use the values, age, experience, amount of money spent, and so on. When you use linear regression, we can use three methods. You enter all the predictors at once, or you can use hierarchical method, and that depends on theory. So SPSS will, you will be seeing the progression of how the coefficients and the significance vary as you move and enter the different variables. If you don't know much about the theory, my recommendation is enter all at once. But if you know that age and experience is what is really you believe is causing this, but then you suspect that another variables also make a difference, then you enter hierarchical. On the first, you enter age, and then on the number two, you enter the other variable, and then SPSS will show you the progression on significance. I'm not going to read them all, but the assumption of correlations are 5. And you know, one is that the two variables should be measured on a continuous scale. If they are not, you cannot use correlation. You would have to use a non-parametric test. They should be paired, meaning the two variables coming from the same person or situation, and so on. The assumption of the regression, like you can see, we only have 5 here. On regression, you have 8. And there are very important assumptions, because as you believe, if you want to predict, linear regression is very demanding. So you have something called homoscedasticity, you got multicollinearity, and we're going to be looking at a couple of those. When you run the assumptions of the linear regression, a lot of the assumptions come from running the regression itself. And then you only have to choose different values. This is an output of the SPSS, where you do analyze regression linear, right? And you enter the variables. You have to choose, in this case, when you go to the statistics side, I choose the Durbin-Watson, and that will be used to test the assumption of independence. It's right here under the residuals. Then you also have to save to test assumption 4. There is an option called save, and the system will create new variables that are used to run some plots. Okay, and then when we look for the assumption of, this is the Durbin-Watson that I said, when we look for the independent of observation, we're looking for a value close to 2. And then remember, I save. Let me go back a little bit right here. The student size and student size deleted. Those are fields that created by SPSS. This right here, PRE_1 and SRE_1. You use those two to create a plot to actually test linearity, right? If the residual form a horizontal band, then the relation between your dependent variable is likely to be linear. But if it shows something like this, you see it's not linear. So you use a visual, not actually a visual, not a pure graphic. Remember, we run the actual linear regression. The homoscedasticity is that the variance is equal for all the values of the predicted dependent variables. And then you also run the same test, and this look like we are fulfilling the assumption. But in this, if you see like an increasing funnel, a decreasing funnel, or a fan shape, then the assumption is not fulfilled. And then we have multicollinearity. Why multicollinearity is important? Well, if two independent variables are predicting the same thing, they're actually going to give you incorrect coefficients. And the multicollinearity is being shown when, look at the bottom right here, age and number of years are highly correlated, 0.98, 0.91. and then look at the model. Number of years a model is negative, even though it's significant, and age is positive. Why? Because it makes sense that age and number of years as a model, they are predicting the same thing. So what I would do in this case, when you look at this multicollinearity, you have to get rid of one of those two variables. I would get rid of age and use number of years. But it's my own choice. Okay, and we almost ready to the DBL. We have different type of regression: linear regression with mediation, logistic, multivariate regression, polynomial, stepwise, and then of course the multiple linear regression. Okay, now we're going to switch to the DBL. Ryan, can you see the DBL?
Yep, I can see it. I can see your model.
Okay, good. Let's go ahead and make run a few exercises here. And I invite you guys, let me quickly see how many people we have. Okay, yeah, we had 23. Good. So we got plenty for the exercise. I want to see if I can predict sales by the amount of advertising. Is this a predictive or correlational model? Don't answer yet, please. How do I decide? Well, let's go ahead and click this, how do I decide? And then, again, I'm repeating what I just said in my presentation. When do we use the design? It's appropriate for exploring problems. Relational is when I want to identify the existing strengths of the direction of relationship. Predictive is if I want to predict relationship. And I want to show you this one. The purpose of the quantitative X study was to determine to what extent, if any, by the way, I pulled this from the University of Phoenix dissertations, if any, a correlation exists between the self-reported intellectual capital usage and the actual usage of intellectual capital on the financial performance of the airline industry in the United States. The variables were the self-reported intellectual capital usage and the measure of actual use of intellectual capital calculated based on financial reports using the value added intellectual coefficient. The question is this correlational or predictive? Anybody, please. Don't be shy. Just turn on the microphone.
Margot has raised her hand. Margot?
Okay. Yeah, Margot, can you speak? Okay, and then use your.
I think she's talking.
She is, but I don't hear Margot. Try to see. Oh, yeah, I can hear now. Okay. Okay, so this is this. This is correlational or predictive. Hello? Hello, Margot? Okay. Well, maybe you can help me with this, Ryan. Anybody then, if you cannot talk, use the chat. Is this predictive or correlational?
Predictive.
Predictive. Okay, so let's go ahead. The purpose of this quantitative was to what extent, if any, a correlational exists. Actually, it was correlational.
Ah.
Right. Now, let's look at another one. The purpose of this correlational study was to determine if a correlation exists between the implementation of Common Core State Reading, CCSRS, in 2010 and 11th grade students and achievement scores for the students with a learning disability who are assessed by the Kansas State Reading Assessment. Correlational or predictive? Don't be shy. Don't worry. It's
correlation.
Correlational. There you go. It was correlational. Okay. And last but not least, I think it's even in the wording. The purpose of this current quantitative predictive correlational was to identify whether there is a predictive relationship between instructional and non-instruction factors of science-based CTE courses and final cumulative GPA. Correlational or predictive?
Predictive.
Okay, there you go. That's predictive. Okay, let's go back to DBL. Now, I want to see if I can predict sales by the amount of TV advertising. Predictive or correlational?
Predictive.
There you go. If you were to answer correlational, then DBL will tell you you incorrectly classified the problem. Review, how do I decide? And that's what we are learning here for future models, completely design the presentation in DBL. But so far, that's the way we're doing it. So you answer predictive, so let's go ahead and answer predictive. There you go, good answer. To predict, we use linear regression. Let's proceed. Okay. Now, let us see below an example to review if the assumption of multicollinearity was met. I'll expand the problem. According to Phil, the largest VIF, look at somebody please mute the phone. According to Phil, is the largest VIF. VIS is a variance inflation factor. It's a measure of multicollinearity. Remember why multicollinearity was important, right? To see if the predictors are correlated. That will really put garbage in your linear regression assumption. Analysis. So according to Phil, if the largest VIS is greater than 10, then there is a cause for concern. Now, so you see what is the value of VIF here. So the question is,
I was thinking of going to the gym, but it was raining. But now
the assumption of multicollinearity met, yes or no? Is the assumption of multicollinearity met, yes or no? Well, let's go ahead and how do I decide? Okay, remember the assumptions. That's the correlation, and that's the regression assumptions. And then we look at the okay, your data must not show multicollinearity. And this is how we test for homoscedasticity. And that's when we plot the graphics. And if you see a funnel, right, that's we don't fulfill the homoscedasticity. I'm just going to go quickly over this. And multicollinearity is when you have two or more independent variables that are highly correlated, right? In this case, I'm going to ask the question. We see age and number of years. And we look at the bottom, when we run the multicollinearity test, we see that there is a strong correlation between age and experience. Is the assumption of multicollinearity met, yes or no? Anybody? Okay, no. Don't be shy. Say it again. Okay, I'm going to move.
He says yes.
Well, assumptions are not met. Why? The assumptions are not met because age, right here, look at 0.98 and 0.91. One is completely correlated. 0 are not correlated. So 0.98, 0.91 mean those two guys are very highly correlated, right? So, and also another way to look at the multicollinearity is looking at the VIF. If the VIF is greater than 10, there is a cause for concern. We have 1.812. So the assumption of multicollinearity, if we say yes, then the answer is correctly. If we had say no, the system would tell me that I answered incorrectly. Okay, now remember the homoscedasticity that I told you, that we plot, and then we plot and we saw like a funnel and stuff. So based on the scattered plot, is the assumption of homoscedasticity met? And don't worry, you always can review this PowerPoint presentation. I know it's a lot in one presentation, but let's go with the flow. remember, if we look at like a funnel type of graphic, the assumption is not met. So is the assumption of the homoscedasticity met in this case? Right? So if we say no, then it's incorrect. Actually, the assumption is met. Then we reach the end, and everything we answered correctly. Now let's move to the next one. We want to know if grades are correlated to students' attendance. I'm not going to go how to either side because it's actually a repetition of the correlational slides that we looked at here before, right? So I want to know if grades are correlated to a student's attendance, predictive or correlational. A brave soul, please. Anybody?
Correlational.
Correlational. It is correct, right? You use correlational. If we had used predictive, the system will tell me that it was incorrect. Because in this case, the key here is correlate. I don't want to know if I can predict. I just want to know if they are correlated. Okay, so let's go to the next problem. Now, and this, remember I told you, one of the classical examples to see the difference between causation and correlation is the example presented by Triola, in which the cost of pizza is strongly correlated with the subway fare. And then in this case, without really bombarding you with the formula or whatever, we don't really have to look at we have to understand this at the high level. We look at it and then we see that the cost of pizza and the subway fare since 1960 are highly correlated with a 0.988 coefficient, right? So does this mean that the cost of pizza is causing the subway fare to go up? Absolutely not. That's what you need to understand on correlation. Correlation doesn't mean anything about causation. They are correlated, but there may be a bunch of other factors. The cost of living, the gasoline, the rent in New York, whatever. So, but in this case, right, the question, going back to the question, what method is appropriate for the scenario, relational or predictive? Anybody? Hello?
In the chat, we have somebody saying relational.
Okay, correlational, and it's true. It is correlational because predictive, right, is incorrect. We don't want to predict. We just want to see that they are correlated. Okay, and last but not least, I want to see if I can predict sales by the amount of advertising. We got half an hour, so for sake of time, we still can play with this. So, is this predictive or correlational?
Predictive.
Predictive, you got it. But if we choose correlational, DBL will tell me it's not, right? So predictive it is, and we are okay. We have one more. In this case, right, it's something we already saw, but I want to repeat it. Do we meet the assumption of multicollinearity in the below example? You see radio advertising and newspaper advertising are highly correlated. I want to know if I can predict the number of records played by the amount of advertising. And then looks like radio advertising and newspaper advertising are highly correlated. So do we meet the assumption of multicollinearity in the below examples? Yes or no?
Yes.
Okay. Yes. Well, the answer is incorrect because you see they are highly correlated both. When two independent variables, predictors, are highly correlated, they're gonna obscure your prediction because they're competing to each other. In some cases, sorry, you want to combine or get rid of one of them.
You got to get rid of one.
Exactly, one of them. Like the example I show you that age and experience, I mean, they're really, really highly correlated, because the older you are, the more experience you have, right? So I think it would be better just to use one. Okay, let's come back to the presentation, and we're going to talk about. I really love this example that I found that I recommend to use. That's for the URMs and chairs when students want to use a mediation. It's simple, it's easy to do, and it really gets, to the point. So mediation is a hypothesized causal chain in which one variable affects a second variable. That in turn affects a third variable. In this case, the intervening variable M is the mediator. It mediates the relationship between a predictor X and outcome. So graphically, the mediation can be depicted in the following way. I'm not going to dwell on what can be this, but you understand mediation, right? You have an independent variable, but there's something in the middle. I don't know. Let's make something up. Amount of time you study at night, and then the mediation can be the amount of sleep, right? And Y could be the GPA grades. I just made that up. So path A and B are called the direct effects, because X, goes through M, and then M goes through Y. So it's not really X predicting Y directly, but there's something in the middle that is actually mediating between. So Bayron and Kenny propose a 4-step approach in which several regressions analyses are conducted and significance of the coefficients is examined at each step. You will see how easy this is. Now, just to show you, right, what I was just talking about, we are not really testing the independent variable from the left to the right directly. We do it through a mediation variable. So the way to test is this. Step 1, you conduct a simple regression analysis where X predict Y. You don't put M at all. Like M doesn't exist. Step 2, you do a simple regression predicting M from X. That's the second one. And then you go to the third one, and then you conduct a simple regression with M predicting Y. And then you do a multiple regression where you put both X and M into the equation. So the purpose of step 1 and 3 is to establish that zero-order relationship among the variables exists. If one or more of these relationships are non-significant, either step 1, step 2, or step 3, researchers usually conclude that mediation is not possible. You get rid of the M. Now, assuming there are significant relationships from step 1 to step 3, meaning you run the first regression and it's significant, step 1. You run the second regression and it's significant, step 2. You run the third regression and it's significant, step 3. You go to step 4. And in step 4, some form of mediation is supported if the effect of M, right, path B, remains significant after controlling for X. That means it is partial relation. If X is no longer significant, when you put X and M together, then you conclude that is a full mediation, right? If X is still significant and M is significant, that support partial mediation. That's the one I recommend for simple dissertations where they want to use mediation, providing they don't have a lot of independent variables. Now, this can get complicated, and I wanted to show you how it is. I'm not going to cover, but I will give you directions. Because the problem with this is that even though you find that M is significant, you don't really find the you don't really test the significance of the indirect pathway. It's not 100%. So an alternative and preferable approach is to calculate the indirect effect and test for significance. And this is what they propose. There are two ways to do it. One is Judy and Kenny, and then you do similar to the one I did before. You do a full X, M, and Y, and then you do the second one that is only X predicting Y, and then you subtract B on the model 2 from B1 on the model 1, and that is called the B indirect. The equivalent approach from Sobel is you do model 1 is the same as the previous one, but model 2 is different. You do X predicting M, and to find the indirect effect, you multiply these twos. This is not covered in this presentation, but if you want to go higher, you can use the bootstrap method, the Monte Carlo method, and the one I recommend is one that is still in the process of creating a future presentation, is a structural equation modeling. That is the Cadillac of the prediction and regression. It really shows you all the path coming from different angles, and then you see all the coefficients and significance. So let's go back and play a little bit more before I end the presentation, and we're going to have like a 15 more minutes for questions. Okay, I'm going to use the regression mediation example. This is more short and quick. Okay, so is this a mediation example? You see that the math ability between math and math self-efficacy, you have a coefficient of 0.47 and is significant. Between math self-efficacy and interest in the math major, you have a 0.36 coefficient significant. And then you have between math ability and interest in the math major, it is also significant. The asterisk mean is significant at the 0.05 level. Is this a mediation example, yes or no?
Yes.
It is, okay? You're right. If you would have you answer no, right? PBL will tell you. Let's look at another one, and that will be the last one. Is this a mediation example?
No.
Indeed. It's not, because religiosity and sense of coherence are both predicting directly into life effectiveness. There is nothing in between. So that would be a yes. Excuse me. No, excuse me. That would be a no, right? It's not a mediation. Very well. So that ends the presentation, and I'm going to stop sharing so we can go and open for questions.
Do you want to turn on your
And then we got 15 minutes for questioning.
So I have a question, Armando.
Hello?
Can you hear me?
Buddy.
Can you hear me, Armando?
I can hear you a little bit choppy, but I don't know if this is me or you, but I can hear you.
Okay. My question has to do with the times when you might have a small correlation between X and M and a larger correlation between M and Y. So between M and Y, you have, it's significant. But if you just look at one of those, like between X and M, it might be either insignificant or very small significance mediation.
If one of them is insignificant, we conclude that there is no mediation, as we saw on the three-path model. If one of them is significant, the SPSS will actually show you the coefficients. It will tell you which one is higher, like a maybe 0.75. The other one would be like a 0.20. And then you can, in your explanation, conclude that the significances of the mediation is higher or stronger than the pure X to Y. But to be honest, the best way to really learn and do this at 100% accuracy is running the structural equation modeling, because that will tell you exactly, right, anything you need to know. I really, to be honest, try to avoid, there are other ways to run for mediation, and like run several linear regressions that they conclude, but they don't do the type of manipulation that I show you, because running mediation models are not simple, especially let's say you have 5 independent variables, right? And you have one that you suspect mediate, and you have a dependent variable. That would be impossible to run with my example. You would have to use a more highly advanced, like a SEM or AMOS.
Great. And there's a question in the chat, Armando. Even though the pizza example is not causal, could it be predictive?
Of course, can it be predictive, right? But you got to be careful, right? Because you got to be careful not to say that the cost of pizza is actually causing the cost of the highway. You can predict in the sense that you put the X in the equation and you expect some value of Y, and indeed you're going to get the value of Y very close to 1970, 1971, or whatever. But for that particular reason, I wouldn't really try to do that. I would try to maybe predict the GPA based on how much support students getting in at home, plus how much time they spend studying, and how much homework they do on a daily basis, and then you can predict GPA. That would be a more stronger way to go. I would just stop with a pure correlation in this case. I wouldn't, just for the reason that it even sounds funny, right? I wouldn't even run a predictor model. But SPSS would accept that, and it would be accurate. Yes, you can do it. Okay, I think Ryan answered to Leo about the DBL, and I just want to say it aloud for people that didn't see the chat. DBL is decision-based learning. It's a software that we acquire, and everybody in the group is learning to try to integrate the most likely next year. For the next year webinars, we're going to be 100% proficient in a way that we do 100% presentation using DBL, because DBL, the idea of DBL is that one student can run DBL by itself, and it's really like a learning tool, right? With tons of different paths based on the answer you provide. And then you always can come back and go to the other path that's the idea. We're still mastering the tool, and that's why, in my case, I chose a two-way presentation, combining both. Anybody? Okay. We got Fred. Can we have a copy of the slides? Yes, you will. As a matter of fact, the slides are placed in the, let me go back, in the research methodology group. Let me go quickly right here, research methodology group. Right, and then I'm just gonna have to share again. Right, let me just share to show quickly. I'm gonna share the application, and I'm gonna share the whole entire screen. So we do have the, where you go to the research methodology group, you go to the research methods webinars, and then right here, in this case, in the July 18, I'm going to put something similar to here. You're going to find the recording at our YouTube channel here. Let me go there to show you. This is our YouTube channel. And then we have right, University of Phoenix. Right, we have the YouTube channel where you can find all the recordings, and then I post the presentations right here. It's going to be a link. You click there, and then you're going to be able to download the slides, and they're always there. We keep in last year's and this year's slides, and we also have 2018 and 2019 videos in the YouTube channel. Can you think of a recent dissertation using quantitative correlational? I don't have it on top of my head, but if you email me, I will definitely send you a couple. There is a place that I recommend a lot, is the Andy Field. Let's see if I can have it right here. Right, you go.
It looks like we lost Armando. I'm going to text him and get him back.
I'm back. I'm sorry, I lost the connection. Let me share to show you a place that I recommend. I'm going to share this. Okay. And then let me go to, I'm going to go to the SAS. This place, Smart Alex. This is the web companion for Andy's Field, one of the most strongest statisticians. And chapter 9 is dedicated to linear regression and correlation, with tons of examples, and also you can download the SPSS and practice. Okay. Any other question?
I'm sorry, where was that again?
You go to let me go back.
You go to the SAS?
Well, I happen to have that bookmarked, but let me show you. This is a bookmark for me. Let me put this on the chat for you. Okay. Let me pull it on the chat. Right here. Okay, that's where you find tons of material. The other place, and I'm going to put it on the chat as well, you go to, it's called the Field Web Companion. This is the web companion for discovering statistics using IBM by Andy Fields. And it's tons of resources by chapter. You find the databases, you find SPSS file, and that let me that on the chat as well for you to be able to download. It's something I strongly recommend you bookmark. You bookmark this because it is important, right? There are tons of examples, tons of, this is the book we use on the SPSS and the RES 720 class. This is the book we use. And then all the data sets are included there. I think Laura Ann also posted you a dissertation. She just right there. She just did it. A correlational study of market orientation and small business performance. Let me just repost that again from Laura. Thank you, Laura. Right there. Laura posted that for the question about linear regression. Okay, we got 6 more minutes. Anybody has any other question? If you don't, I'm going to stop the recording and be waiting for my email with the link to the slides and the link to the YouTube. My email right here. I got 2. And right there. Either one can work. You can also, Ryan is also he's a co-chair with Mansoura, and he's a great resource to get anything you need related to the research methodology group. Ryan, would you like to put your email on the chat, please?
There we go.
There you go. So anything you need, or anything not only you need, but tell us how can we improve this? I guess we're getting better in the tools. I think the tools are really cooperating now. Everything is working smoother than it was before, and I think thanks to Blackboard Collaborator. Anyway, okay. Is that it? And then I really appreciate the attention to this matter, your collaboration, and and then the next presentation. Let me go to next presentation is August the 1st. Program evaluation. Dr. Ryan Rominger is going to introduce program evaluation designs as used within dissertation. August the 1st. Okay.
I'll be using the same DBL software in that presentation, and our hope is to allow individuals into that software to run through the models and run through different case examples in order to better learn the content, whether it's phenomenology or correlational designs or program evaluation. For those of us that have used it this year, we're hoping to be able to open that up, but we're still working on the logistics of that. So stay tuned for that piece. We'll be announcing it when it's available.
Thank you, Ryan. Okay, stopping the recording now.